Okay, this is the second video for Lewis structure. So in this video, we're gonna learn how to draw a Lewis structure of water, which is a covalent compound. Okay, so here's what water is: water molecule, H2O. Now the Lewis structure of hydrogen, okay, let's say, is this. Okay, the Lewis structure of oxygen is this. Okay, you can review the first video for this. But the structure of water has almost nothing to do with the elements in there, okay? So the first step is going to be for any covalent compound, okay? For any covalent compound, the first step is you have to count total number of valence electrons. So it's similar to calculating the molecular weight. Okay, so you have to count each element, each atom, and count how many atoms and how many valence electrons in total. So in the case of water, hydrogen has one valence electron, oxygen has 6 valence electron, but there are two hydrogens, so 1 times 2 plus 6 equals 8 valence electrons in total. Now what we're trying to do here is we're going to use this 8 valence electrons, okay, to make sure everybody in the compound will fulfill the octet rule. So let's make a structure, okay, lay out the atoms in a way that as symmetrical as possible, okay. So 2 hydrogen atoms, 1 oxygen atoms, you would put hydrogen and oxygen in the center, another hydrogen. Okay, you won't put the atoms out. You would not do this H2O. Okay, you want to put them as symmetrical as possible. And then you're going to use this 8 valence electrons to connect 3 atoms together. Otherwise, if they're not connected, this is not one compound. Now, here's what you want to be careful with. Okay, you would let's say this is the center atom. Okay, this is surrounding atoms. Okay, there's another surrounding atoms. You're only supposed to connect the center atom with surrounding atoms. Okay, with a dash line. Okay, these dash lines represent covalent bond. Now, each covalent bond is composed by a pair of electrons. Now, once you put down at least one covalent bond between each surrounding atoms with central atoms, now you're connecting 3 atoms in one compound. But keep in mind, okay, the covalent bond you're forming here, which utilizing 2 electrons each, has to come from the valence electrons you have. So you got to keep doing the math, okay? So 8 valence electrons in total for the entire structure. You've used 4 of them to form 2 covalent bonds, okay? So next step is going to be now for each atom, okay, in the structure, you have to fulfill the octet rule. Otherwise, nobody would be happy. Okay, everybody has to be happy. The only exception, though, hydrogen does not. So this is a quoted octet rule. Okay, for most of the atoms, okay, we already said that most of the atoms it wants 4 pairs around it. Okay, it wants 4 pairs. But for hydrogen, okay, hydrogen only wants 1 pair. Okay. If you think about it, hydrogen has electron configuration of 1s1. The fully occupied s orbital will be just 1 more electron. So 2 electrons is perfectly happy. Hydrogen will be perfectly fine with that. So we already have HOH, and there's 1 single bond connecting each hydrogen with oxygen in the middle. Okay. Now this is a pair of electrons already. Okay. So this is a pair of electrons already. So in other words, for hydrogen, okay, covalent bond, the whole point is it will make it look like it has what it has. Okay, it doesn't necessarily have it really own the electrons. Okay, so in the hydrogen, there is a pair of electrons next to this hydrogen. So if you look at this around this hydrogen nucleus, you make it look like it has one pair of electrons already. So this hydrogen is happy. As we've said, that hydrogen only wants one pair of electrons, and so is this hydrogen. Okay, so this is a pair. Now for the oxygen in the middle, okay, currently it has two bonds attached to it. Okay, two bonds. Each bond is a pair of electrons. So in other words, this oxygen currently looks like it has two pairs of electrons around it. But everybody wants to have four pairs. Okay, four pair is what most of the atoms would like to have. So is this oxygen. And keep in mind, okay, for this 8 valence electrons, you can't overuse them, but you can't have any left over. So now we have 4 electrons left over. And this oxygen has 2 pairs, and it's missing 2 pairs. So we're going to put all these 4 electrons around this oxygen by putting 2 pairs dots around. So now I've used the other 4 electrons, which has 0 left over. This is very important though, okay? You have to have 0 at the end. Keep doing the math. Now, if you look at this oxygen, okay, it's got a 1 bond, 2 bonds, another pair, another pair. So this oxygen looks like it has got 4 pairs already. So far, everybody has what they want. Okay, so this is the Lewis structure of water. I mean, circling, you don't have to draw the circles here, okay? I'm drawing this for the teaching and showing purpose, okay? But here are a couple of terms we have to be careful, okay? For instance, well, you may say, okay, the bond you said is a pair of electrons, and dots here are also pair of electrons, but I don't think they're the same, right? No, they're not. For instance, the bond, okay, the dash line you put down here. And by the way, usually people don't put dots here, okay, put just dash line, one dash line, another dash line here. They are a pair of electrons, but they're shared pair. Like this bond is shared between this oxygen and this hydrogen, and the other pair is shared between the other hydrogen with the oxygen as well. They're shared pairs, so they are called a bonding pair. Okay, so is this pair. Now, these 2 pairs of dots, okay, next to oxygen, they are not shared. They exclusively belong to oxygen. They are called a lone pair. So let's summarize what we just did, okay? We start from counting total number of electrons. And then we lay out atoms, okay, how many ever you have. And try to focus on having one central atoms and then other surrounding atoms. And make sure you connect each surrounding atom with central atoms by one bonding pair. Just one bonding pair, okay, each. And then keep doing the math. You have to take out the electrons that's being used in the structure from the total number of valence electrons. And once you have that, you have to start working on the surrounding atom first. Make sure every surrounding atom has either 4 pairs or 1 pair if it's hydrogen. Once they have what they want, and then you're gonna start working on the central atoms. Give it whatever it needs if you have leftover electrons until you have no more electron left over. So when you count pairs around any atom, so including surrounding and central atoms, you need to add up bonding pair, lone pair, total into 4 pairs. Okay, it doesn't matter how many bonding pairs, how many lone pairs you have. You have to have 4 pairs in total, except hydrogen. Okay, except hydrogen. In this case, oxygen has 2 lone pairs, 2 bonding pairs. That makes up 4 pairs perfectly. Okay, so this is the Lewis structure of water.